In this video, we'll be talking about the basic graphs of sine and cosine. What's important to know about these graphs is remember that the functions sine and cosine come from the trigonometric functions which come from the triangle. So all the values that we're actually going to be using for sine and cosine to graph them on the xy coordinate plane are specifically coming from those triangles. Keep in mind also that anytime that we're graphing sine and cosine, we're going to be talking about the values based on radian measure. Because if we talk about them using degree measure, they're not going to make sense, or at least all that much sense, in an xy coordinate plane. So the first thing we're going to do is we're going to go ahead and do what we normally do with every basic function. We're going to create a table of values, specifically the x and y values. Now we're going to do this for the function y equals the sine of x. So in this case, again, I'm plugging values in for x. Those values that I'm plugging in are going to be your angle measures. Your angle measures, again, for these functions are going to be using radian degrees, or radian as opposed to degrees. So over here, I'm going to go ahead and start with some basic values. We're going to go with 0. We're going to have way down here pi over 2. Now, these two values are the ones that if you think about the way that the function is built from the triangles, we can't get pi over 2 or 0 degrees from the triangles. So we look to the unit circle in terms of those values. And if we're talking about sine, when we plug in 0, we're going to get the value of 0 back. If we plug in pi over 2, we're going to get the value of 1. Then in here, we're going to go ahead and fill in all the values between 0 and pi over 2, starting with pi over 6, going to pi over 4, and then finally pi over 3. These are the three main values in the first quadrant. Again, you can get these three values specifically from the triangle. Then what we're going to go ahead and do is when we plug these values in, we should be getting values back for sine. Again, it's a lot easier to pull these values out of the unit circle than it is to pull them out of a triangle, so that's what we're going to do. If we look back at the unit circle, the sine of pi over 6 should be 1/2. Then when we plug in pi over 2, we're going to get radical 2 over 2. And then finally, when we plug in pi over 3, we're going to get radical 3 divided by 2. Now we can continue this process utilizing the unit circle to fill in the rest of the values. As we do that, after we count the values, 1 pi over 6, 2 pi over 6, 3 pi over 6, next one is 4 pi over 6, which is going to be nothing more than 2 pi over 3. Then we're going to go ahead and have 3 pi over 4. And then we're going to also have 5 pi over 6. So in this case, again, filling in these values, notice that when we plug the values in over here, we get back values that are y values in the second quadrant. The second quadrant has the sine functions as being positive. So we're going to get the exact same values, but they're going to be in the opposite order. Now again, once we get down to this next value, the next value is pi, and we're back to 0. Then when we start doing all the values below that, now I'm not going to write all of those other values out, but just remember, again, you're looking to the unit circle to identify pi over 6, pi over 4, so on and so forth, and plugging those values in. We want to go ahead and graph this to the best of our ability on an xy coordinate system. Now notice how I'm drawing this function, or this particular set of axes, with a heck of a lot more space on the x-axis than on the y-axis. And that's, remember, because the y values, the values that sine can spit back, are nothing between other than -1 to 1. So for the basic function, I'm going to go ahead and put a -1 down here, about the same distance, a +1 up here. Next, I'm going to go ahead and I'm going to figure out what all these values actually represent. Remember, we're plugging in these x values of pi over 6, pi over 4, and so on and so forth. So utilizing our calculator, we can go ahead and plug those values in. Pi divided by 6 is approximately 0.523. So this is actually 0.523. Again, we're going to do this for pi over 4 as well as all the other values. So second pi divided by 4, alpha equals, I'm going to get 0.78. And then for pi over 3, we're going to get 1.04. So notice 1.04. I'll go ahead and do pi over 2 just to get an idea of where that's going to land as well. And that's 1.57. So we're getting these values, and notice that these values are actual numbers. And this can continue on forever, giving us, again, approximate values for all of these. I'm not going to focus too much on these ones in terms of their approximations. I just want to get a good idea of what this is going to be. Now, what's important to note is that the distance from here to here is approximately 1, so the distance to that location right about there is approximately 1. But it's also important to note that's technically pi over 3. So I'm going to mark that as pi over 3. Next, what I'm going to do is I'm going to go ahead and make sure that I note that 0, 0 is a point on my graph. I also want to make sure that I'm going to have specifically 30 degrees between these dashes. And when I say 30 degrees, I mean the distance from here to here and the distance from here to here should be approximately the same. And that value right there should be pi over 6. Then if I cut that space in half, that should be my pi over 4 location. Now again, this is very much similar to the way that the unit circle is graphed in regards to the distances of those dashes on the unit circle. They're approximately comparatively the same. Again, the distance from here to here should be 45 degrees, and then I should have the similar distance from here to here out to my value of pi over 2. That's a little bit longer than I want it to be. I'm going to put it here, pi over 2. So ignore that dash there. So in this case, again, you'll notice here that that's pi over 2. Now what I'm going to do, because this thing is cyclical, again, all these numbers are repeating in some pattern, I'm going to go ahead and just take this distance here. I'm going to repeat it over here. That's going to give me pi. I'm going to again take that distance, I'm going to repeat it over here. That's going to be pi, 2 pi over 3. Sorry, 3 pi over 2. I'm going to make that distance one more time, and that's going to give me my 2 pi value. So in here, there are 6 dashes. 1, 2, 3. Every single one of these locations, there's 1, 2, 3, 1, 2, 3, 1, 2, 3, such that it cuts evenly through pi over 6 to pi over 3, then pi over 3 to pi over 2. Those distances should all be about the same. And then same for these ones, same for these ones, same for these ones. So what we're going to go ahead and do now is we're going to go ahead and register what the y values are. So I'm going to have radical 2 over 2. I'm going to need to know what that value is. So let me go ahead and plug that into my calculator. Second radical 2, divide that by 2, and that's approximately 0.707. And then the radical 3 over 2, I'm going to go ahead and do that one as well. That's going to be 0.866. So all of these numbers down here are actually the same numbers. This is 0.866, this is 0.707, and so on and so forth. So I'm going to go ahead and plot these values to the best of my ability. I have 0, 0 as 1 point. Again, the x value of 0, the y value of 0. Then at the x value of pi over 6, I'm going to have a y value of 1/2. So about halfway up, I should be able to plot a point. The next one is 0.707. So that's a little bit higher, almost halfway, but not quite halfway between this point and that dash. So maybe right about there. Then at pi over 3, the 1.04, again, that's approximately 1. We should be close to 0.866, or getting closer again to that dash at 1. And then at pi over 2, we should be hitting 1. So you'll notice that it kind of is sloping up into a nice smooth curve here, and that's the idea. What we're going to do is we're going to fill in the other 3 values. Again, they come down in the exact same pattern, so right about here, and then we're going to have another one here, and then another one here, and then we hit at pi the value of 0 again. Again, notice how I didn't fill in all these values, but I more or less know how these values go. If you're not comfortable with this, please fill in the entire table for every single value on the unit circle in regards to the function of sine. And you'll see that this function comes up to 1, then comes back down to 0. At 3 pi over 2, we're going to hit our -1 value, approximately right there. And at 2 pi, we're going to go back to 0. The big dots that I've placed in here, those are the most important points for the sine function. There is always going to be 5 important points in every single one of these trigonometric functions. And those 5 points will designate more or less what the graph should look like. All you have to do, again, the way these work is you understand how the points are built, how all of these extra points are plotted in there, and we're going to fill in the rest of it based on that information. If we can identify these 5 points, we should understand how the graph is going to scale. Now also keep in mind that every one of these trig functions is cyclical in nature, which means that I can continue adding on points past here, 0 pi over 2, 1 pi over 2, 2 pi over 2, 3, 4, and then way out here somewhere is going to be 5 pi over 2. If I were to plot that point, this thing should go back up again. It starts repeating itself for the sine function. It has a period of 0 x to 2 pi, which means that after that moment, it starts repeating itself. This is not the domain of the function, this is the period of the function. This is how long it takes for it to start repeating itself. So it's going to come back up to this value of 1 somewhere out here, and it's going to do that. We're going to continue this on forever in this exact same cycle. Concept is that we can go in the negative degree measure, or negative angle measure. So if I were to look at pi over 2, cut over to here, so negative pi over 2 somewhere over here, we should be sitting again at this point. Logically, it's the same point, and we should be then going down to that location. So we should have a point down here at -1, and again, it should look something like this, that continuing on forever. Now, When graphing these basic sine and cosine functions, we don't need to see that excess point. In most cases, the question will say, graph one period of the sine function, okay? Or graph one period of this particular function. So in that case, I don't need those extra lines to emphasize the information there. I'm just going to graph just that piece. So this can also be done for the cosine function. Again, we can build ourselves a table of values. We can go ahead and work through all the information. We can still identify that the period of the cosine function is still between 0 and 2 pi. We can go ahead and fill in the table of values, but we're not going to do that for this case. For this case, I'm going to focus on more of a basic understanding of how the function is built. Again, you can build your table of values, x and y. You can have 0, you can have the other three values, and then you can have pi over 2. Then you can hit pi, then you can hit 3 pi over 2, and then you can hit 2 pi. Again, these are the main 5 points that you need to feel comfortable with. If we can get these 5 points down for sine and cosine, then more or less all the other information makes sense. Now, it is also important to understand that these points aren't always the same points we're looking at. Depending on how the function is changed, will change what these points are in terms of their importance. So we're going to cover that in other videos, but for now, the cosine function starts high at the value of 1. At pi over 2, it hits 0. At pi, it goes to -1. Remember the unit circle again. What the x value in the unit circle is the cosine value that we're supposed to get back. When I hit 3 pi over 2, I'm back at 0, and then at 2 pi, I'm back at 1. So if I were to try and graph this function, this is more or less how I do these functions from this point forward. I'm going to be real smooth about this. I'm going to be real lazy about this. First off, I know the furthest point that I can plot in terms of one period of cosine for this is 2 pi. I'm then going to cut that value in half. If I cut that value in half, that's going to give me pi. That's the middle location. That's this one right here. Now notice again, 2 pi cut in half, and then cut in half again is going to give me this one. So I'm going to go ahead and cut this in half again and get pi over 2. Then, to get this middle value over here, it's technically by adding these two together and dividing by 2, but that's a lot of extra math work that we don't need to handle. So let's just divide this by 2, divide this by 2, and then take this value and multiply it by 3. Because really, it's one of these things, then 2 of these things, and then in this spot, it's going to be 3 of these things, and then 4 of those things. So we're always going to divide by 2, and then to get this middle one over here, we're going to multiply by 3. Don't ever forget that you need to plot that 0 point. It needs to be in there. So I'm going to go ahead and plot this using an amplitude. Amplitude is the furthest distance from the x and y, or sorry, from the x-axis. So that in this case, the amplitude of this function is going to be 1. We're going to go ahead and have 1 as the high point. Then we're going to hit 0, then -1. Back to 0, then 1. Now be very careful when graphing the cosine function. There's a lot of forcible habits to just draw a line straight through like this. Okay, with the way that my pen is moving, this would be an incorrect cosine function. Keep in mind, it should have these values very similar like this, which means that it should be a nice smooth curve, not a straight line in any way. So I should draw what almost behaves kind of like a circle in some form where, again, it curves down. And then again, notice how I pick my pen up. I'm going to go ahead and angle it again, trying to draw a nice smooth curve to that location, a nice smooth curve to that location, and once again, a nice smooth curve to that location. So that's going to be your cosine function, such that, again, it starts high, goes to 0, goes down to its low point, goes back to 0, and goes to high. Now, again, this graph can be seen by plotting all of these points from the unit circle or the triangles, but that's the basic idea of how you graph a sine function and a cosine function. Also make sure that, again, you understand that this does continue on in both directions, such that it can go on cyclically forever. But that's your basic sine and cosine functions. Again, sine starting at 0, going high, 0, low, 0, and cosine starting high, going 0, low, 0, back to high.